All right, troops, so I am ready to start what we talked about. For those that are tuned into this, if you're working on the video, which like I said is perfectly fine, but I'm gonna go through every October 9th problem, starting with 1 through 9 on the workbook, and then go through that. We'll take as much time on each one as you need to till you feel like you answered the question that I need to answer for you. Plus, as you said, recording this, so it's actually that, so when I get done today and you needed to go back, say, what was number 5, so on. So we got the best of both worlds, okay? All right, so first things first, everybody be able to see this okay? Okay, all right. Okay, poke the nose out here so I can breathe. Don't fog up my glasses so I can see. Okay, so number 1, so basically talking about same thing. Got our 100-gram sample, okay, all right, yeah, of this particular isotope, which is nitrogen-16, okay? So it says, it wants to know how long it takes to decay to that. So I had this big sample that decayed down to this big sample in from here to here. I'm just doing a little visual aid, 21.6 seconds. And they want to know what's the half-life. So we first of all figure out how many total half-lives, which we know that, if you remember, keeping it simple, if this is what I start with, okay, and I am now going to have it, and everybody was clear that we understood that each time it goes through a cycle of a half-life, half of whatever's there in the mass goes away, okay? So, first half-life obviously goes to 50, okay, choo. And then it goes to another half-life, which makes it 25, choo. Okay, then the third half-life, again, goes to 12.5, which is what we are looking for, all right? So, little visual aid there, of course, making it easier whether you need it or not. 12.5. All right, so I know that it took 3 half-lives to get to here. All right, and it took a total of this. So just very simple, the question is asking what's the half-life, so it wants to know what's the individual unit for each one. Okay, so just I'm dividing 3 into that, which should have gave me 7.2, and I listed in seconds. So that's basically saying, once again, every 7.2 seconds, this happened. Then another 7.2 seconds, this happened. Then another 7.2 seconds happened. Got us where we're at, and it asked, okay? So I'm just double checking all my answers on that, okay? Pretty straightforward. Questions like this is what I would expect for you guys to master. Not the tricky ones, just the straightforward. Here's your sample, it went to this in this amount of time. How old is the half-life? You know, if you can do this, boom, next week on the quiz, we're getting to practice, but you should knock it out. Okay, so that's really what, I mean, just to be able to grasp that basic one, okay? So this is number 1. Does anybody have any questions on this one? Okay, we're okay on this one? Okay, I'm gonna move on to the next one. All right. So I'm erasing even though I'm videoing it, so it's still there. I'll upload it later. You can go question at a time if you want. All right, number 2. All isotopes of titanium have a widely varying half-life of 800 grams, okay? Choo, choo, choo. So I got 800 grams of that total thing, all right? All right, it decays to 100. So like I did my little big shapes if I need to, no big deal. I just do this for a little visual aid. Went from this to this, from 800 to 100, okay? And it did all that in this amount of time right here. A lot bigger, 639,000 years. Okay, so it's the same as the problem before. It wants to know what's the individual half-life of titanium. All right, so I'm going to do the same thing I did over here. Okay, understand the basic principle. All right, it halves. 800 goes to 400. Okay, choo. Has to go again because I'm not where I want to be yet. 400 goes to 200. Okay, goes through it again. Choo. That's what I'm looking for because that matches up. 100 grams. 100 grams. So once again, I went through the magic number, 3 half-lives, okay? So then I would just take 3 half-lives into this total. 3 and that's 2, 1, 3. So each half-life, so every 213,000 years, okay, this half. So that's 213. Then another 213. Then another 213 to get me to where I wanted to be, okay? All right. that's how we got it. So see some good nods there. I know I said that. So same problem as that one, just different isotopes, different masses, different time frame. Okay? Okay, with number 2. Okay. Because I wouldn't say I was getting strange questions, but I get a lot of questions. But okay, I see that, but how do you know? Remember, okay, always go back to the basic rules. We know that every time a mass goes through a half-life, whatever's there is going to go half away. So I just do this little tally. Like I said, well, first of all, I got to know how many times it went from that to get to that. And then if they give me the total time, just however many times it did it, I divide it in to find the individual unit. Okay? It's like saying if I have a dozen eggs and I eat 3 eggs a day, how many days will that last? 12 eggs, make 3 a day, 3 into 12. Well, okay, I got four meals worth of eggs. You know, so oh yeah, it's the same thing like that. If I'm trying to, you know, budget out that or whatever. Okay. I even go as far as I forgot, but I used to go. Okay, this is when I was in training a lot. I'd say okay, and I would make all my meals, and I'd say okay, I got a loaf of bread, and if I use 3 pieces of bread a day, when I got to go back to school to get a loaf of bread, I'd count them, and I'd figure out how many days. Okay, so I have 3 pieces. That's 1 meal. If I have 2 of these meals, yeah, and I would figure it out that way, and I had this little. And that might be extreme, but then I had this little pad of paper, and I knew exactly when I had to go to the store to get either bread or eggs or, you know, something like that. That's just me. And I mean, so yeah, the attention to detail. So one of the things probably some of you guys don't know is the reason I kind of got that. Some of my mentors back because of sports and whatnot were like that as far as they would tell us to keep lists, keep that, and keep track of that stuff. So I guess, you know, they always referred to it as keeping us organized. And, you know, it worked for me, you know. Okay, so 1 to 2. All right, number 3. Okay, if I got a 200-gram sample of sodium-24, decays 13 grams. All right, decays to 13 grams in 60 hours. Okay, so now I'm saying, is the half-life, what is the half-life of this radioactive isotope? So there's 208, same thing, goes to 13. So I got 208 grams. All right, so me with my math, so I don't mess it up, put my little quick calculator, so I can do that. All right, so I punch it in, I say, okay, so don't mess up my math, 208. Okay, I got to get it down to 13 grams. So let's figure out how many half-lives. So obviously half of that is 104. Maybe I can do this math. Half of 104 is what, 52? Half of 52 is 20. Oh, I can do this in my head. Gosh, 26. And half of 26 is 13. All right. So once again, there's what I'm looking for. 13 grams is what I went from 208 to 13 grams. Okay? And that time frame of that mass going from that to that took 60 hours. So then if it took 4 half-lives, just divide 4 into 60, wants to know, it's the same problem as before. 4 into 60 goes 15 times. 15, so it took 15 hours to do this, 15 hours to do that, 15 hours to do that, 15 hours to do that, for a total of 60 hours to get to that. Okay? So the answer was 15 hours on number 3, 15 hours. Okay? 15 hours. All right? So that's number 3. All right? All right? So far, so good? Okay? All right? That's number 3. All right, number 4. Okay, number 4. All right, if a half-life of iodine 131, once again, same thing, just kind of blasting these problems into your head, okay, of just your basic going. How long will it take a 50-gram sample to decay to this? So once again, here we go. I got 50 grams. I need to get it all the way down to 6.25. So I'm going to do what I know, and that is have my isotope. All right, 1 half-life, 50 to 25. There's 1. 2 half-lives, okay? 25 goes to 12.5, okay? 3 half-lives. Looks like it's going to go to my 6.25. 6.25. Just halved it each time. Half to boom. 3 half-lives again, okay? Once again, if each half-life, they said, or the total was 8.12 days. How long? What is a half-life at I-13? So 3 into 8.10 was, oh wait, no, I'm sorry, what was that? Oh, how long did it take? Oh, if the half-life of iodine 131 is 8.1 days, how long did it take? Oh, so times it. Oops. If that is the half-life, so yeah, 8.1, they gave it that, so it says this took 8.1 days, 8.1 days, and 8.1 days. Okay, add or times by 3. Should have had 21 or 24.3. So it should have been 24.3 days. Okay? So same problem. So instead of giving you the total amount, they wanted to know, there's a half-life. It went through 3 half-lives. What's the total this time? So instead of dividing that number, I timesed. Okay, that's all it did different. Okay? Same problem. They just times and wanted to know what was the total time instead of the individual. Okay? All right. You see that? Okay. All right. Nodding heads. Okay. Okay. If not, stop me. We'll back up. Okay. So that's 4. Okay. 4 down. Okay, number 5. The half-life of hafnium. Oh, my voice cracked. Hafnium. The half-life of hafnium 156 is a really small amount. Just because it's in milliseconds almost doesn't mean it's harder. It's just a small number, that's all. That's what calculators are for. Okay. How long will it take 560 grams to decay to 1/4 its original mass? Okay, we can do this. 1/4 its original mass. So if you need a little visual aid, 1/4 would be, 1 half-life would be half, and that leaves me half, so that'd be 1 time. And then if I halved it again, doesn't that leave me with 1/4? So that tells me it went through another half-life. So it went through a total of 2 half-lives, that's all. It said, how long will it take to decay to 1/4 its original mass? Everybody agrees 1/4, 1 half times 1 half is 1/4. So just half this twice. Half of 260 is what, 250, 280? Is my math right on there? 280? Yeah. Okay. And then, okay, so, how long, okay, will it take to go from 560 to, okay, so I don't need to do that. I'm sorry. I don't need to do that math. So if each half-life, guys and gals, is a small number of 0.025 seconds, and we know it took 2 half-lives to get to 1/4 the original mass, just times this by 2. So that should have been, your answer should have been 0.05 seconds, basically, right? 0.0, okay, yeah, I see the nod of heads, you guys are right, perfect. So I just then times this by 2, and I got 0.05 seconds, okay? So first, I could have divided this. If it had asked me how much mass, I would just divided this from 280, then win another one, and it would have been, what, 140, but it didn't ask me that. How much of the mass is left? It wanted to know how long did it take to get to 1/4 its mass. So once again, I'm still doing all the same stuff, just it's asking me something different, so I have to do it in different orders. That's all, okay? So that's number 5, all right? Number 5, okay? All right, number 6, chromium 48 has a short half-life of 21.6. How long will it take 360 grams of chromium to decay to 1125? All right, so if I got 360, we're right back to the old school of just straight out. Wants to know how long. If that's the individual half-life, be nice, computer, camera, don't do that. Okay, so I'm going to then just keep having it till I get to 1125. So half of 360. All right, so I got 360 divided by 2, 180. Divided by 2, it should be 90. Okay, divided by 2, 45. That's 3 half-lives in. Divided by 2, 22.5. That's 4 half-lives. Okay? Yep, looks like it one more time. Divided by 2, 11.25. So it went through a little more, but it went through 5 half-lives to get to that. 5 half-lives. Okay? See how I did that? Just because it was a smaller number, bigger number, and I had to divide it more, doesn't make it harder. I still keep the same 1 or 2 procedural steps, do what I know until I get to the number desired or the value that I need. Okay? So I went through 5 half-lives. So once again, if chromium-48 has a half-life of 21.6, and it went through 5 half-lives, and wants to know what's the total, I would just times what? 21.6 times 5, which I came up with 100. If I plug it in my calculator, I came up with 108 hours. So what that is saying, that when this thing went from 360 to 1125, it took 108 hours, because each one of these times, that's 21.6, 21.6, 21.6, 21.6, 21.6. Okay, I add that all up, that's 108. So every cycle of 21.6 hours, half the sample went away. Okay, do you have a question? Oh, thought so. Right. So that was number 6, right? Yeah. Good on that one? Okay. All right, sure. Okay. All right. Okay. All right. Number 6. All right. Number 7. Potassium 42 has a half-life of 12 points. Same stuff. Just beating this in your head. 12.4 is the half-life. I have 848 grams, okay, of potassium. Well, how much of 848 will be left after 62 hours? So same thing. So now it's asking me if this is the total and divide this into this, that's going to tell me how many half-lives I need to divide this, because it said after 62 hours, how much of this left? So I just grab my calculator. Okay, a little different again. I'm just changing up, the same rules, just asking them in different order. 12.4, 62. All right, so 62 is the total hours, okay? And each half-life was 12.4. Divide that into it. Survey says 5. So this takes 5 half-lives. All right, so that means I'm going to divide this 5 times. 1, 2, 3, 4, 5. And that'll be my answer here in a second. So I go back to simple square one, 848 divided by 2, there's 424, divided by 2 times, that's 212, divided by 2, that's 3 times, 106, divided by 2, that's 53, and divided by 2 for the last 5th time is 26.5, okay? So what that's saying is, after 62 hours, this sample went all the way down to 26.5. 26.5 grams. Yep, that's right. 26.5. Okay? That's problem 7. Any questions? Okay, we'll keep moving. All right. All right, let's scoot this up just a smidge. Yes, ma'am. Awesome. What's up?
So what would be the answer for that?
What would be the what?
What would be the answer for that?
Oh, right here. So if I went through 5, so the answer would be 26.5 grams. Because it asked how much would be left of this after this amount of time. So each times this, I just divided that. So I knew I needed to divide this 5 times. And that's where I just did half, 1, 2, 3, 4, 5, 26.5 grams. Does that make sense? Okay. Good question. Any other questions on 7? Okay, moving on. So there's 7. And the good thing about it, like I said, we're recording this, so I'll be able to hands-on and you can always go back and check if there was something you missed. Okay, now, these aren't tricky, but you see a giant scientific notation. It's going to be, I don't want to do that one. I'll just ask Meyer. Okay. So here's how I like to do it. I like to deal with whole numbers. So all I did is, okay, if we know this is spot on, that's my half-life, 5730. So 1.79 times 10 to the 4th, I'm going to make it a whole number. Okay, so hopefully we remember. Just move that decimal over 4 places. 1, 2, 3, 4, add a 0. So this number is the same as saying 17,190 years. Okay, so rethink it. If that's my half-life, 5730, and my sample is 144 grams, okay, it wants to know, after this amount of time, how much is left of that after this happens. So most of you said, "Uh-oh, I saw this scientific notation and I didn't know what to." Yes, you do. Same thing. If that's my half-life, I just divide it into the total, and it came out to be 3. 5730 divided into 17,190 is 3. Most of you, when you did this, you punched the sequence into your calculator with the exponent wrong, and it gives you the wrong calculation. That's why a lot of honestly, your mistakes are calculator based by hitting in the wrong sequence. Like a lot of times you notice, I know it's simple when I say divide by 2, divide by 2. Sometimes if you punch it in, you say, oh, it went through 5 half-lives, so I'll just divide by 5. You don't get the same number. No, 2. It's simple. I mean, because the calculator is going to do the order of operations differently. Okay, so that's what happens. You know a lot of times what you're doing, but because you put the sequence in your calculator wrong, it doesn't give you the right answer, then you're like, I don't get it. Okay, so you have to be careful. That's why, luckily, I like to write stuff out. I see it, it sticks in my brain. If I need a calculator, it's right there, and I still write it down. So having scratch paper really does help. Okay, so that into that. Everybody see where I got 17,190? I just factored this whole number to a whole number. Divide that into that. Should have came out to be 3. So I'm just going to divide 144 3 times, because that's what I wanted to know. How much is left after this time frame? So half of 144 was what, 72? Is that right?
Yeah.
And then half of 72 is 36.
Yeah.
And then half of 36 should be 18. Is that right? Yeah. So the answer was 18 grams. It's maybe difficult as you thought that was because you saw something you hadn't seen before. It's the same problem as 1 and 2. I just asked you to scientific notation, okay? And we have it down. So it is. It's the same as problems 1 and 2 and 3 and some of the others. It's just I gave you the information a little different, okay? Don't let that throw you a curveball. Stay in there on it. Take it to left field, okay? A little baseball analogy, okay? Lefty, bring the ball, stay on it, take it right back where it came from. Good to go. What is he talking about now? Okay, last one on worksheet number 9. Number 9, same thing. Scoot it up. Okay, so I got a giant number again, so I like to factor it out. So let's first factor out this one, which is 9 zeros to, or 9 places less. That'd be this, 820. So that's 2,820,000,000,000 years. Whew, that's a long time. Okay, and this one is 704 million. Okay, so what it's saying is if the half-life of uranium-235 is 704 million years, that's slow. Okay, that's the ultimate Jolly Rancher right there, dissolving in your mouth. Okay, and I have 12.5 grams of uranium. 12.5 grams of uranium. Okay? Remain after this time frame. How much of the radioactive isotope was in its original sample? So I finally threw you a curveball with this one. How much was in the original? So, what this is saying is, I have 12.5 grams now. It wants to know, what was it before it was at 12.5 grams? So this is one of the few, instead of dividing, I'm going to times, once I figure out how many half-lives. So if this is the half-life, everybody, and this is the total time, everybody, I divide this into this, and I should get, I believe, 4. Anybody? I believe it's 4 half-lives. If you divide, big calculator, 704 million into 2.82 trillion, 820. It should be 4, I believe. Yeah, real quick, check for me. I believe that's right. Just a big number, but like I said in a calculator, like that should be 4. If you just straight long division. Okay, you make it 4. You did? Okay, yeah, it is 4. So yeah, because I know calculators sometimes go into place. So what I did is I got on my computer and typed in free calculator, and it had, I could type in, and that's how I made sure, because I couldn't type it in my little calculator. So all it's asking now is think backwards. This is where I'm at. So I need to go 4 times. 1, 2, 3, 4 the other way. So follow me why I'm going the other way. It wants to know, what was I before? So I need to know how much I'm going to times. It has to get bigger. This is where I'm at now. It's asking me the original, so I got to go backwards. So it's asking me, and I won't ask you that. I'll just flat out tell you, I'm not going to ask you something on a quiz unless like this, unless I might say the bonus, okay? But I want you to be able, it's practice in recognizing that problem. So, real simple, ladies and gents, is if I have 12.5, and I know it went through 4 half-lives to get to that, I'm just going to times it now by 2 4 times. Times 2 is once. So now 25 times 2, I'm at 50, times 2, I'm at 100, times 2. So what this is saying is at 2,820,000,000 years ago, this uranium was 200 grams. And over the course of this time frame, it deteriorated on this. So it's saying that after 1 half-life, okay, it went to this, that's how it got to that. Do you see how I did that one backwards? Okay, I know it was difficult, and I'm telling you, I'm looking at the video. I will not ask you a question like this on the test, only for extra credit if I'm feeling happy about it. There, see? Video witness. But I'd like you to learn how to do it, okay, or recognize it. It's better problem-solving skills, okay? So hopefully you see that, and then you see that stupidness that I did there. If you have to think, and you'll go, okay, all right. But once again, that's the half-life. It's giant, but it's still, it doesn't matter if it's 5 or that. Don't let the big numbers go, I can't do this. Yes, you can. Slow down, half full. What do we know? Convert it to a whole number. Convert it to a whole number. If that's the total, that's the individual, divide into that, I get a nice tiny number of how many times I either got to divide this. In this case, though, I had to times it because I wanted to know what was the original mass. Okay? Any questions on that one? If not, okay. If not, although the good thing is, all those explanations, I know it's a lot of numbers in your head, it's on tape, and I'll upload that if you, I'm going to upload it anyways, but if you need it, it's there for you. Okay? All right? So that's 1 through 9. Okay? I'm going to stop this, take a drink of coffee, and then we'll start on the other ones. Okay. So it won't take forever to upload. Oh, good, and I was right in line, too.